Hey, Madison, we're loading up MuBot here. It is time for afternoon office hours. What questions do people have? What are people working on? MuBot is now awake. MuBot is awake with so many quotes, so many things. Can I add multiple counters? Can you go over how to do the write-ups for visualization number 3? I've watched the video in old office hours, but I'm so confused. Yeah, definitely. I think I only do one counter. It's too bad. I'd like to do more counters. Let's hop over here and let's do some of the write-ups. Let's do this. Which write-up are you working on? Are you doing the mosaic plots or the side-by-side box plots? Which of those would you want to talk about? Let's open up our 10,000 jump things. Here we go. Mosaic plots or side-by-side box plots? I thought it should... Am I crashing jump? Oh, jump's crashing. Jump is crashing. Number 1, the mosaic. Okay, let's do mosaic. I'm going to clear row states. So let's make a mosaic plot. Rows, clear row states. Computer's being a little bit slow. Let's do analyze, fit Y by X. This is going to make a mosaic plot right here. Let's go another zoom in if the computer can handle it. I need to reset this computer. Let's go with if people have broken a bone. So broken a bone is going to be my Y. This is not the one you're doing by gender. Gender is going to be the X. Does gender explain why someone's broken a bone? This is probably one of the easiest ones to read right here to understand what's going on. You don't need this test section. Your screenshot should have them. I don't think you have to do them side by side, but it's not horrible. If I do this, someone's going to want me to do this. Well, first off, let's go right here. Go here and remove total and column percentages. You only want count and row percentages. So let's point to some very important things. How would we write this one up right here? And this is a good screenshot. Like, I'm going to show you the screenshot you need. Once again, make sure when you screenshot only the parts of the screen you want someone to be looking at when they look at your display. You can always crop your screenshot. So when you bring it over to your 1,000 Microsoft Word documents, you could always go in. 1, we're going to make this a little bit smaller. And 2, you could go in and crop your screenshot. Like if I had extra bits on this screenshot, I could go here, picture format. I can go here to the crop the selection, and I could remove things. Like if for some, do not remove that table. But if for some reason you didn't want that table, you could remove it. Don't do that. That would be not the right screenshot. So we now have our visualization. With the visualization right here, and let me double check something because I don't think we required additional stuff. I'm going to check one thing. I don't think it says to put them side by side because it's not too hard to do, but visualization number 3. Yeah, it doesn't say to put them side by side. It's not that hard to do it, but since it doesn't say it, I'm not going to do it. Okay. So I want us to know some things right here. When you do the write-ups, 1, mention the percentages, or these are the numbers, but I always call them numbers, like mention the percentages, mention the numbers. I've helped a few people and I've been like, make sure to mention the percentages. And then 2, compare and contrast them. Is there a relationship? That's an association. Okay, so with this right here, Madison, what do you notice about breaking a bone in gender? What do you notice about breaking a bone in gender right here? Like, what is a key thing you notice? Like, if you look up here at females, broken a bone versus not broken a bone, like the relationship between this should be a little bit easier to see, and then we could go into an explanation. So we have females broken a bone, females not broken a bone. So this is the conditional distribution right here. Let me highlight it. We talk about it. The conditional distribution is right here for females who have or have not broken a bone. So given somebody is female, and that is the same information we see down here in the table. So how would we write this up? How would we talk about this with percentages? How would we say, looking at the conditional distribution of females, it appears that what? How would we then give the numbers? And this percentages are probably going to be better here because we can then compare the male to female percentages. You know, what do you think we would say? What do we say? We should probably, and we could compare and contrast to begin because there's a few ways to do this. There's no a perfect way to do this. But when you examine more than 40.13% of females have broken a bone. Exactly. So you could say 40.13% of females have broken a bone compared to 54% or 54.65% of males who have broken a bone. Now you're doing a comparison We can also see that females were less likely to break a bone, with 59.87% of females having not broken a bone and 45.35% of males having broken a bone. It seems to me that there is an association. Great job, Madison. 20 points for everyone watching live right now. We see right here that there does seem to be some sort of relationship between breaking a bone and gender. Does that make sense, Madison? This is a much shorter write-up here because you're not really comparing that many groups, but it's clear to see that it doesn't mean if you're male you're going to break a bone. It's just males have the males in general, just the conditional probability given someone is male, they're more likely to have broken a bone. Even though 45% of men have not broken a bone, they're just more likely. And so what does a relationship or association mean? It means if you know X, which this is the X variable on the bottom right here, if you know X, it gives you some information about Y. Like knowing someone is male would have you believing it's more likely they've broken a bone, but still it's very possible they did not ever have broken. You're like, oh, you're male, you've broken a bone. It's like, no, they didn't. They're just more likely. Males in general are more likely to have broken a bone. Is this making sense, Maddie, right here? Notice how I'm going to talk through the write-up a little bit right here. Like this is what I would write. I'd write, this graphic shows that there is a somewhat strong relationship, or I could say moderate. There's a moderate relationship between gender and breaking a bone. We see this, for example, where 40.13% of women have broken a bone, opposed to 54.65% of men have broken a bone. This is about a 15% difference in the probability of breaking a bone between men and women. To contrast this, we also, it's the complement, so it's basically the same thing. We also see that 59.87% of women have not broken a bone, compared to 45.35% of males who have not broken a bone. Once again, showing that men are more likely to break a bone and women are more likely to not break a bone, to have broken a bone. Is this making sense right here, Madison, as I talk through it and I talk about how the probabilities and how it's associated, and I could even throw in at the end, knowing someone's gender would give you information. Let me mention one thing because I want to make this super clear. You should say relationship or association in there somewhere. I might even say mention association. Yes, this is making more sense now. Yeah, so on ours, are we going to need... you don't have to like label all of them. Just kind of like, as you're seeing right there, do you see maybe some groups where men are more likely to be this group and women are more likely to be this group? And you could compare and contrast that to say like, this group, like men were more likely to be this compared to women who had this probability. Women were likely to be this, where men had this probability. This seems to indicate that there is a blank association between gender and political view. And if you're understanding that, you should get it because it's showing you the conditional distributions. There's all the conditionals, and great job, Maddie. Or no, Madison. Sorry, I've had a lot of Maddies. So if you're like, yeah, that's my nickname, sure. But I read this teacher subreddit too much. And people like, they're like, a student posted, they're like, my teacher calls me a nickname that I don't use. It's okay. Okay, good. I swear, I've probably had more students who are Madison who go by Maddie. And so, yeah, like, what is it? I think I've gotten stuff that says like brain on it or Brian spelled with a Y, and I don't care. But I know some people will. Like, I mean, I don't want anything official saying brain on it because my name's not Brain. But I've definitely gotten things that say brain. Like, I just laugh. I remember, like, I think I got an award one time. It said Brain Stevens. And I was like, whatever. Whatever. Brain Stevens, that's my name now. I'll legally change my name because of that award. Good thing it wasn't like a big award. It was just like some certificate I got as a student. So are you wondering about the other one? What else? It is your guys' office hours. You get to choose what we do. And yes, whatever topics you want to cover. But I think that thoroughly kind of explains what to talk about with a Mosaic plot. Can you go, yeah, Viz 6? Let's do Viz 6. Let's do it. Let's do Visualization 6. We did a little bit last time on it. Visualization 6 is going to be decision trees. Thank you, Sarah. So let's go right here. Assignments. I like this because I can kind of, I try to send people the links to these videos. I should like make a master list of like where each one is. And so people could like quickly reference them. So check this out. With this completed right here, I was working on when I put in the variables and they were supposed to use, I got a long list after hitting OK. Ooh. Can you send me a screenshot of it, Sarah? Are you on the Discord? Discord's so easy to send me like a quick screenshot. I've got 9+ message. You can see the 9+ in Discord. I'm always keeping up with like what's in Discord, and then and please use Discord, use GroupMe, whatever you want. Yeah, send me a message in Discord, and as long as your name's like Sarah, let me double check, make sure I got it on the other screen so I can pull up Discord. Yeah, it's on the other screen. Okay. A bunch of messages. Class over screen back off. I just have the Discord on the other screen, so that way I'm not pulling up Discord during class. There you go. If you send me it, I can address. And if you're like, if you say I can show the picture, I'll copy the picture over to the main screen. Okay, so we are predicting. Oh, this is a quantitative one. Good stuff, Sarah. This is a quantitative Y. So I think I know what you're saying. You got a different display, and you asked where's the color of the points thing. So I'm gonna label that part of the video from this morning like explaining decision trees, not visualization 6. Because this is a quantitative Y, which is going to change. So you were very right to say, I don't see color of the points. Where's color of the points? Because color of the points is only when the variable is what? When would you be able to color groups? That's the hint. When would you be able to color groups for a Y variable? So this one is anticipated starting salary. And this morning I did Greek life. So what's the big difference between anticipated starting salary versus Greek life, which is classic? Where's my thing over here? Wrong button. I hit it. I should never have hit it.
Know your variable types.
Timers. This is supposed to be over here under effects. And let's go over here to effect. There we go. Know your variable type. Let's go back to timers and remove that off of timers. And there we go. This is, I think I've showed this a billion times, but this is how I do all my fun, like, different things that I do on the screen right here. So I've got about a billion buttons. What do you think of that puppet shark? he might one day make it over the main screen. He's currently on the effects screen. So when I do all the effects, so it's just so helpful to have that. And I've got all my switching between scenes when I do these things here. Okay, so what do we got going on right here? We have a quantitative Y, and let me look at Sarah's thing right here. Let me see. I think it's you right there. Let me double check the name because I'm too afraid. I don't know how to yep, that's you. That is correct. And there's another issue. I see an issue. Okay, I'm going to recreate what you have right here and show the issue. And let's talk. I definitely need to label this visualization 6. So the issue with, I'm going to put a thumbs up here so I remember to reply to it. And so we can go into more detail right here. Discord's just so easy to communicate. So easy. You can be like, hey, Brian, I have a question. Just hop on a call. I don't know about Brian's love of Discord. So let's do the variables right here and let's analyze them. Where's the data? You know what? Let me download the data. How about that? How about that? Catch me with the data. How about that? So here's the data. There's the data. And so what kind of variables do we put in a decision tree? I should have said this morning because you hit the issue. What kind of variables go into a decision tree? They go into Y and they go into X. What kind of variables go into decision trees? Because there's a little asterisk that I forgot to mention this morning. What kind of variables go into decision trees? We got to hit the button again. There's 2 types of variables that go in decision trees.
Know your variable types.
Quantitative. And the ones that don't go in decision trees are identifiers or things that act like an identifier. And let's just take a look at the major column for a second right here. Here's major. You can do a quick analysis, which I rarely do, by clicking that little graph button. This is not part of the assignment. We're just going to look at major. And what do you notice about major? What do you notice about major? And especially when you look at things like kinesiology business, kinesiology pre-med, supply chain management, supply chain, all these different things right here. What do you notice about major? It almost looks like an identifier. It's the way people spelled it. You know, this variable needs to be cleaned. This is the perfect example of messy data. So this is not a variable we will use. So what we're going to do right now, actually, you know what you can do? You can just go right here and delete that variable. Boop, delete. This makes life way easier when doing this. So we're going to look at the other variables. What do you think I'm going to do with this and why? So this is, I guess, if I wasn't ever going to clean major, like if this was my data and I was never going to clean major, I would just delete it because I'm not going to use it. It's very messy data. and it's almost acting like an identifier with as many groups it has. When does something act like an identifier? Well, one, this is an identifier. So just for right now, we're going to leave it out of the decision tree. Yep. And the easiest way to do that is just to delete it. If you're managing data, I would not suggest deleting stuff. But for this assignment, just to like not deal with it, we can just delete it. We can store the data and re-download it or whatever. So a lot of times people ask me, like, when does something become an identifier? Let's look at two variables right here. We have whether or not someone's been arrested and someone's favorite phone app. And which of these do you think would act like an identifier? Like, it's not an identifier, but it would act like. Like, think about been arrested probably has what levels? Let's go look at it. Been arrested has levels over here. So here's the been arrested variable. There's the been arrested variable, and here's your favorite phone app. So with all of this right here, the banking app. What is banking app? And you can tell like how old this is. Like, I think Instagram would be way higher nowadays. Canvas with a smiley face. I don't know if there's the Canvas smiley face app. So which of these would act like an identifier? So when you think about what is an identifier is something that is always unique for every level. So this is not an identifier because you can see repeats. I mean, there is spelling differences, but it looks like Snapchat and Snapchat are the same. So it can't be an identifier because there are repeats. But it almost acts like an identifier because there's a lot of levels. If you look at the variable itself, we can go here to analyze distribution, and you'll look and you'll see that there are a lot of levels to this. So, you know, just going through this, there's so many levels that there's a lot of uniqueness. But does that make sense, Sarah, that we don't want things that are an identifier or act like an identifier? Does that make perfect sense right now? The instructions probably say to remove these variables. They should. I'll double check while I ask that question. Take the three, except for the specific variables that should be excluded. Yeah, just making it clear right there. Yep. So which of these variables are here? I'm going to mention three variables, and I'm going to delete this thing right here. So remove Q1, and what else did you delete? Let's list them. This is like major tips right now. You ready? Let's go through here. Q1, Q15, not that one. Favorite phone app. Where's favorite phone app? Favorite phone app, and I think that's it. Pretty sure that's it. And why are we removing these? Why am I removing major? Why am I removing original row number identifier? And why am I removing favorite phone app? Why am I not including these in a decision tree? Why are these being removed from decision tree construction? They will not make our tree. Why are we removing them? So I want everyone to know why we're doing it. I know it's like, because the knowledge part of this could be on the test. Decision trees use quantitative and categorical variables. They do not use identifiers or things that... Is there a way to get more attempts on Canvas quiz because of picture? Oh, email me, Parker. I'll add you another quiz attempt. Email me. So this is a categorical variable. Major is categorical, and favorite phone app is categorical, but they act like what? And Parker, email me. I'll make sure you get another attempt since it cut it off right there. If there's ever a technical error, like if there's a difference from technical error, like Brian, my computer's having issue. I'm so sorry. That's like, no, go to IT immediately, please, 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 please. But then there's like Canvas glitched and made an error, and I'll be like, yeah, whatever. Let's fix it. I don't want you to, because you shouldn't be responsible for you get 2 attempts and 1 attempt the screen didn't load. That's completely beyond your control. So there's a difference between like dealing with I think you'll get it. So favorite phone app is categorical, but because of how many levels it has, it's like the explanation of why this has problems is a very statistical thing to explain. It's because I'll explain really, really briefly. If you have like 50 groups, there's so many ways to divide things up. Like think about 50 groups and I say, put these 50 things into 2 groups, which that'd be 50 items, choose 2. So if you have 50 items and you just have to choose like 2 groups that everything goes into, how many combinations could you use? And there's tons and tons of permutations of the ways you could put them into groups. And because of that, this variable, which has more than 50 groups in it, will dominate the splits. It'll control the tree. And it's probably just doing random chance things. Um, yeah, and so it was Q15. Hopefully it was Q15 one of them also. Yep, because there's so many levels. Yeah, Alexis, we'll do that next right here. So we'll make this Sarah right here, and then Alexis will find the standard deviation for one of these variables. So let's delete out these variables, delete columns. I wouldn't do that if I was really working with data, like if I'm like going to use this data set elsewhere. But for this visualization assignment, I'm going to make my life a lot easier. You bet, Madison. Let's see here. Can you talk a bit about the other question box with the plots? Yeah, let's do that. We're going to do standard deviation next, and then we'll talk the other ones. So now we're going to go to analyze, predictive model, partition, and then we're going to go and we're going to take, so yours is quantitative, but here's what you do. Check this out. You ready? Now that we only have these variables, I can't stress this enough. We only have these variables. This is what you have, right, Sarah? You only have these variables, right? You only have these variables. You delete out the other ones. You see Q15 is missing, and you see Q44 is missing, and you see Q1 is missing. Hit Control or Command A. Now hold Control or Command and select the variable you want. Then drag all of these highlighted variables into the X, and then click the variable you want and put it in the Y to repeat the process. And then we'll hop around a little bit. I'm going to remove all this. Let me just remove all this. Don't do what I'm doing here. I'm just showing the process again. Click Control or Command A, then hold Control or Command and click the variable you want. Then drag all the X variables into the X slot box right here, and then grab the Y variable and put it here. Now this is going to look a little bit different because it's quantitative, and you can see the Y quantitative scale over here where some student had a 0 GPA. Not good. And if you select a point by accident, you can always click away. A lot of people had this happen with their box plots. Student asked in class, hey, wait, my points are all dim. What happened? If you just click somewhere in a blank space, or you go to rows, clear row states, it'll deselect the data you've selected. So now I think it wants us to split 3 times. Let me double check. Take 3 splits. Yep, there we go. And to go here, we go split, split, split. You could do this in 2 screenshots. So if you notice right here, we get an asymmetric tree. So your screenshot I would take of this down here on the bottom. I would take this as a screenshot, and that's good enough. Yeah, I didn't get any edge. That's your bottom screenshot of the tree, and then I would take the top screenshot too. So there's the bottom of the tree, and then I would take a top screenshot of the tree. And we'll mention this really briefly here. Does it want the leaf report also? It must want the leaf report. Leaf report, yeah. Take 3 splits, your decision tree, and create the leaf report. So to create the leaf report, go right here and click leaf report. Red arrows are where your options are at. And yeah, take the leaf report and take a screenshot of the tree. I have way too many things open. Ah! Like, Brian, why does your computer go slow? 37 Word documents, that's why. There's the leaf report. And I did catch a little bit of that graphic right there, so I am going to go here. This would not be points. I would be mad if a grader took off points, but I am a perfectionist, so I'm going to crop that image right there and make it like that. And yeah, awesome, Sarah. I thought this would get you ready to go right here. I thought this would be the help you needed. And then I'm going to take a screenshot of this right here. I'm going to change the width of it a little bit. And yeah, I'm just going to quickly analyze this really, really quickly, and then we're going to find the how to get the mean and standard deviation. So now we go back to our document, our 1,000 documents. We go back here to the start, and we drop it in and make it smaller. We center this, we center the whole page, and yep. So what I would see right here is that the people with the highest group, the people with the highest GPAs are younger individuals who have an age less than 20, and they are in the honors program. If you see, it's this group right here. Please remember, just a really quick note for anyone watching this, that this is leaf 1, leaf 2, leaf 3, leaf 4. This is leaf 1, leaf 2, leaf 3, leaf 4, magic color change pen. And at the very top of the screen, you can also see, it's a little hard to see in this one, leaf 1, leaf 2, leaf 3, and leaf 4 is the little leaf right there. You have to look where the divider lines are right here. You have to see where it divides it off right there. And that should be it. Leaf 4 should be very tiny, and we see 92 people as opposed to the bigger samples. So hopefully, is this making more sense how to read this when you see the 4 groups right here? It's harder to see in this one because you have to look for where the lines go down to where it cuts the groups. If you look really close, you can see a line for the mean for each group. But hopefully that helps, and then just kind of talk about the differences. This is group 1 right here, which are people who are greater than or equal to 20. You can also see the description right here at the bottom. And they had an average GPA of 3.65. This is group 2, people who are not in the honors program and are male. You can see the description right there. So that's got it. Can you help me? I'm not. Yeah, Ansley, great. Yeah, awesome. And I think, yes, Alexis asked that also. Let's do this. Which question are you working on? Is it a My Pearson one? Because let me pull up some of my Pearson work. Thank you so much. Because another person has this question too. So it's a really great question to do right now. So I'm going to pull up the assignments. Oh, Alex, I need to fix that. Alexander, if you're watching, my Pearson was crashing on me earlier. So I was trying to use my Pearson to change something and it was crashing. And that's not good. I went to pull up a thing and it just wouldn't pull up. So let's see. Yep. Which one are you working on? If you give me the start of your question, I will do that exact question and show how I would find the mean and standard deviation for it. So if you tell me your question, I will tell you the exact way. Yeah, the first. Oh, we did that just earlier, Mary Beth. Check out the very start, the first 3 through 15 minutes of the video. I can go back over it, but I think we're going to, after this, we're going to do the second write-up. So check out the very start of it. A center for, ooh, yep, good one. Oh, wait, 2 seconds. I didn't do all the questions. Let me go to here. It looks like other people concur. Let's go to replace questions. A center for. Thank you so much for the start of the question. And a center for. Here we go. Where's the center? Ah, here we go. Okay. So I'll show you the tricks for this one. Should we speed run this? Should we see how quickly we can do it? Okay. So here's the tricks for this one right here. The numbers are 150 and 349. I don't know. So for this one, when you do this, we found this out we did this one this morning, but don't worry. I want to show how to find the mean and standard deviation and find all the numbers. There's 22 numbers right here. With 22 numbers, the median is going to be the 11.5th number, which is going to be between these two right here. Just to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.5. Yep, still right there. So this is not a fun median. It's 120.5. Not a nice perfect number. And then the, is it 3 numbers in? Let me double check because these numbers give it away. The first number down here, ooh, I really hate how they do this. The numbers are, there's 22 nations. Something seems weird today about the numbers. Maybe I'm just going mad. Did they finally change it and fix their question? It looks to be that 1, 2, 3, 4, 5, 6. Yeah. 1, 2, 3, 4, 5, 6. Yeah. I think I'm just losing my mind. So it's 6 numbers in from each side is going to be Q1 and Q3. Don't worry, we don't have you find that during the test. I just want to reiterate that multiple times. You will not be finding Q1 and Q3 during the test. I don't think we have a single question that does that. I'm very against that. I just want you to understand Q1 is the 25th percentile, Q3 is the 75th percentile. The distance between them is the IQR. So let's go ahead and find the IQR of 547 minus 368. And it is 179. So that is the IQR. And then we're going to take our numbers from below, 368. And we're also going to take 547. We can also put in the min and the max here, which are the 5-number summary. So 250 and 588. And now the big question becomes, how do we get this mean and standard deviation? So go right here and go slowly with me. Here's how you get the mean and standard deviation for any data set very quickly. Copy to clipboard. So we're going to copy to clipboard. So you click this little button, copy to clipboard, and then make sure it says tab delimited, then hit Control or Command C. So Control or Command C, click Done, go into Jump. You can be anywhere in Jump, just ignore that, and go to File, New, Data Table. File, New, Data Table. So under File, New Data Table, we're just going to open a new data table in Jump. And from here, we're going to go to Edit. And for this time, we're going to go to Regular Paste. We're just going to paste in the numbers. So now when we paste in the numbers, we get all of our data. So with this data now inside of Jump, we're going to go to Analyze, Distribution, Analyze, Distribution. And then we're going to double click this variable. And now, once we click this, we do have all the information. I just like to stack it. But there's your mean of 438.5. And there's your standard deviation of 90.3. 438.5 and 90.3. 438.5 and 93. I'll put it over here. I'll cheat. I'm putting it on the screen. So 438.5 and 90.3. As long as I didn't mistype anything. And let's look at the distribution. Here's where jump can really help. Is this right skewed or left skewed? Who in the chat knows? Is this right skewed or left skewed? It's not that skewed this time. I'm a little worried I might get this one wrong. Let me look at the skewness. This is a cheat you can do to see. It's going to have a little bit of positive skew. This one's more symmetric this time today. So do you notice this is the mean, the diamond, and the mean is a little bit above the median. If this is skewed, which you see, it's a little bit skewed. I wish one of these answers said it's a little bit skewed. And I know this is pulled out more to the left. And let's change the shape of the histogram, because the bin widths can mess with your eyes. So this would not be a good test question right now, and I'm so 50-50 on it. It's really iffy. This one's such an iffy one. You see there, it looks left skew, but like to be a very technical statistician person, and I'm gonna go symmetric on this. I'm gonna go symmetric because that number right there, if that is 0, it's a symmetric distribution, and if it's positive, it's right skew. If it's negative, it's left skew. So this number right here is actually the numeric measure of skewness. So rather than like debating if it is skewed, well, one, if it is skewed, what direction must it be skewed in and why? Which I kind of stated earlier. If it is skewed, we would say it's skewed to the right because the mean is higher than the median. Also, the positive skew indicates that also with this numeric measure, which you don't need to know this. This is, it's a good help to like cheat and know the answer. So I'm going to go symmetric. It can only be this answer. Ooh. The distribution is symmetric because the mean and median the distribution is symmetric because the mean and median are approximately equal and the quartiles are approximately the same distance from the mean. Okay. I think that's the giveaway. I think that one right there is the giveaway. Okay, yeah. Okay, they're not going to say symmetric. Okay. That second answer right here, do you see the quartiles? Does everyone notice the quartiles distance right here from the median down to here and the quartiles over here? Are they saying the distance from the... I'm going skewed. Not today, my Pearson. Not today. It was that last part right there that made me iffy on the answer. This part right here is what made me iffy when we look at the graphic. So I'm going to bring back up the graphic. But that last part of that answer really made me iffy, if I'm going to say that. You're welcome. You're welcome. Does it make sense? The last part of the answer said the quartiles are about the same distance. So if you look at this right here, I'll draw it in as we talk about this. Here is the mean, and here's the upper quartile. And let me go away from the hand tool. So here's the distance from the mean to the upper quartile, and here's the distance from the mean to the lower quartile. So if you notice this, there's a bigger distance here than there is here, and that would also indicate right skew. So when I saw this and they were saying that that was the same as this, I was like, no, those aren't the same. So I didn't want to confirm an answer that said maybe that's their additional information they put so someone like me would get it. But that was a tricky one. It's a very simple question, but when we do, let me just make this very clear. When we do skew on the test, I've always stood by us doing questions of skew where we draw something like that. That's right skew. As long as number line goes from 0 to 100, that's right skew. And then you can always, like if you're really concerned about statistics, like if I'm doing stats stuff and I want to know if something's skewed, so one last review of skewness right here, which everyone should know. Let's go right here and let's go, oh no. And let's do the following. I want people to tell me, it's a little 320 for everyone. I want you to tell me what way is that distribution skewed? What way is this distribution skewed right here? Who knows what way that distribution... What? Oh, I know why. What way is that distribution skewed? Too many things to remember. What way are those numbers skewed? Those numbers are skewed to the what? Then we'll do more visualization stuff here. That is very obviously what skew. No one knows. No! No one knows the skew. Not a single person knows what way that's skewed. Good thing. Thank you so much, Kirsten. Let's throw everyone some points. Thank you, Maddie. Let's give everyone some points. Thank you so much. That is very obviously right skew. We should know that instantaneously. And here's the thing. I also know that this will give a positive number when we look at the skewness of it. So when something is right skew, it's going to have positive skew. When something is symmetric, it's skew. So these are random normal numbers now. When something is symmetric, its skewness is going to be closer to 0. So you know what's interesting is that has a skewness about as much as our other one, but all these have a skewness value close to 0, and they're all just random normal curves. All those are very, very normal. Yes, everyone's seeing each other in the chat right there, but you don't need to know positive skew is right skew, negative skew is left skew, but it makes sense. Like negative is the lower numbers, so left skew. But once again, that's why I get mad at my Pearson questions sometimes. I'm like, that's not a fair question. Like, it's mostly symmetric with a little bit of skew. So we can use our words. Yep, Q3 minus Q1. And also, here's the thing though, and also this question, probably one of my least favorite questions, they use these numbers down here for the IQR. So when you're doing this question, make sure to use these numbers. Does that make sense, Ansley? With this question right here, use these numbers. And if you subtract them the wrong way, just make sure it's positive. Like this is the incorrect way to subtract them, but IQR is always a positive number because it's like a distance. Like if I said, how far are you away from home? And you said negative 179 miles, I'd be like, do you mean 179 miles? And you're like, no, negative. I'm like, well, distance is distance. So, oh, that's so awesome, Maddie and Kirsten. That's so awesome. That's, yeah, no, I love it. Like, you know, it's like, I think when people are on like, this is more like just a real quick thing, and then we'll do people want to do visualization 3 next, part 2? Is that what people wanted? Go ahead and say what you want us to do next. We're just in a lull between here right here. But I think our class is, yep, Madison says yes. I think our class and what we do is a bit different because, like, do you ever hop on a Zoom meeting and someone's in the Zoom thing and you're like, oh, hey, so-and-so, like, well, one, because the chat, like, it's just a different social media thing. Like, Zoom is not social media. This is social media. This is, like, a whole different thing. Karina says yes also. So I think here, while Paul Visualization 3 while we do this, we'll put on some chill music. My favorite chill song right now. A little chill music. Visualization 3,333,333. My nephew likes asking me about big numbers, like, and I told him a trick. I said, there is no biggest number. And I think he didn't quite understand that there's no biggest number. But I said, all you have to do is say +1. So I said, I'm going to tell you a number, and I want you to tell me a bigger number. So whenever I say, like, 10, you can say 10 plus 1. So if I say 100, what do you say? And he said 100 plus 1. I said 1,000,000. He said 1,000,000 plus 1. I said, what about a trillion? He said trillion plus 1. I said, what about a quadrillion? He's like, he didn't know how to say it. What about a quintillion? What about a octillion? So I don't know. I find it fascinating, like just the world around us. There's always something to learn, always something to understand. It's really big when you're a child. The world gets smaller as you get older. But then if you like continue your education, learn more of these things, it gets bigger. I don't know. The world shouldn't be tiny. The world's a really awesome big place. Let's go over here to visualization number 3. I can't find it. Here it is, found it. Visualization number 3 is back. Let's do this. I'm clicking random buttons. Just a random question regarding the visualizations and jump. There's a place to save the graphs and everything as an image. Would you rather us screenshot it? You can do that. If you want me to look at it, Sarah, just tell me. But you can do that method. I think I never used the, what is it called, innate method of doing it, but I usually screenshot. I like doing screenshots because I can control what it is. Like if I see it on the screen, I can screenshot it. So I like doing that. So I think we're doing the write-up now. We're talking about how to do the write-up for the side-by-side box plots. So I'm gonna do the side-by-side box plots a little bit quickly. We're just listening to some chill music. We're gonna find a data set Brian can use. Looks like this one. I guess we've already done this. So, well, it's crashing. There we go. Crashing done. To show how to do this, go to Graph and go to Graph Builder. On this one, I had a lot of outliers. Is that normal? Yep. You can get a lot of outliers. Don't worry, mine has a lot of outliers. It'll look pretty crazy. Turn the music down a little bit here. And so let's go ahead, go to Graph Builder. And here's what we're going to do. We are going to take, I'm going to vanish from the screen. So many outliers. We are going to go right here and we are going to, this is not going to be like yours. We're going to go here to gender and we're going to put gender on the x-axis. This is just a categorical X. So here's a big thing you should know. Side-by-side box plots have a what X and a what Y. 10 points in the chat, who knows? Side-by-side box plots have a what X and a what Y. Side-by-side box plots have a what X and a what Y. So box plots are always this. They're always quantitative. So box plots have to be quantitative. Like you have to have a quantitative variable in your box plot. Like you always have to have this quantitative. Like you could just do, like you can do a box plot. So here's a box plot, or you could do side-by-side box plots, which just puts different groups. So there's side-by-side and there's a box plot. Does everyone understand how box plots are bivariate? Nice job, everyone in the chat. And great work. Let me add the points. I already typed it in. But does it make sense that box plots are univariate quantitative, and then when you do side-by-side box plots, you're going to have a bivariate display with a categorical X and a quantitative Y. So it literally just breaks it apart into two groups. There's univariate quantitative, one quantitative variable being displayed, and here's bivariate because we're breaking it into two groups. You can see the second variable on the axis right here, and then the Y variable is still quantitative. So a trick you can do, you don't have to do this, don't redo your graphic, you've already done it. You want to go here, this is just a trick, and take the same variable and put it over here to color. So that's just a trick, you don't got to do it. I like it though. And we're going to make this smaller, or not, why not? And then we're going to click done. Oh, no, don't click done. There we go. So now we have everything we want to display. If you don't have the color here, perfectly fine. That's just Brian doing things. Now we're going to make this smaller because we don't want that big of a graphic. Really? Really? There we go. Now we've made it smaller. Jump's being weird today. So I'm making it how I want it. So don't worry if your graphic doesn't look perfect, but here's the thing you need to make sure you do. Go away, other graphic. The thing you need to make sure you do is you need to take a good screenshot. And there's multiple ways to take screenshots. You can use, like, I think, Sarah, were you doing something like this here, Sarah? I think you can do this method. I'm going to try this method that I haven't done in forever. Hey, that worked great. Yeah. That's the selection tool. So Sarah might have done that right there. The selection tool in Jump is up here on the toolbar, and you can use the selection tool and then copy paste with that. I don't use that method a lot because I'm worried about how the format it's going to use. So let me double check. Cool, that's that. And I like to just take a screenshot this way. This is perfectly fine. And knowing how to take screenshots on your computer is a skill I would highly suggest people know how to do. Please note my screenshot. This is a good screenshot. What would happen if this was my screenshot? If this is my screenshot, let's go over to our Word document. We're in the 40s now, I think. 39, we're about to 40. What would happen if this was my screenshot? Bad screenshot, gotta lose points. What can I do in Word right now to fix my screenshot? Points taken off, you got it. And what can I do to fix this? I can actually fix it here. So it's better to take too much than too little. Crop it. Nice job, Madison. Thank you so much. We can click the image. We can go to crop. Once again, a great skill to know. Where's crop? There's crop. And you know what? You can do a better job sometimes with this because you can more finely tune it. You can see exactly what you're about to black out in the image. And there we go. Just click outside of it. There we go. So that's a great screenshot now. We could resize it a little bit, and we've done it. So make sure you have a nice looking screenshot. Here's the way you know you have a good screenshot. If you were in a board meeting and you displayed this to somebody, thank you so much, Karina. So if you displayed this in a meeting and you were like, here's my presentation, and would you be proud of it? Would you think this is a good image to display during a meeting? How did you move your max, min, etc. over? It wasn't on the edge. Yes, Madison. Let me show that again, Madison. To move those values. Where'd it go? Okay. To move those values away, you have to. Oh no, that's that graphic. Good, here we are. To move those values, go down here to the bottom axis, and you can grab. Oh, you can't see it. You can grab this bottom axis. Do you have that option right here, Madison? Great question. Don't worry, you won't get. Oh no, 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 no! I'm grabbing the whole axis. But you can move this axis in and out like this. So just go to the very edge of it and do this. But I think if you go too close, you'll grab the whole thing and move the whole thing. Don't worry, they shouldn't take off points if it's too close. Like they should not take off points for that. I'm against that. It makes it bigger. I might have to hop on like Discord to see it, because I would think you could go grab the hand tool, and so the hand tool's up here. These are like different toolbars and jump, and then you could try that. Just make sure it's right here near the corner. Oh, you might be grabbing right here, Madison. You might be grabbing the arrow. So let me zoom in, put it in the center, so you can see really well. So there's a difference between if you're right down here and you grab the arrow. Like if you get this will increase the width of it. Awesome. And if you grab the hand tool, that'll do it. So you have to wait for the little hand up here. Nice job, Madison. Thanks for asking. Class is not over. Wrong buttons. Man, I'm so lucky. I want to give a big thank you. This is something the Haslam College of Business bought for me, like my department bought for me. I have another one of these. And just so you can see, last semester, this is what my Stream Deck looked like. So I use a Stream Deck so I can click buttons. This is what it looked like last semester and all the buttons I had. And this semester, it's completely a lot more. So big thank you to Haslam College of Business, my department, everyone, because all the things I can do. Yeah. Big thank you. I feel like I need to make him say yeah louder. Is he at his top volume? 2 seconds. 2 seconds. Is he at his top volume? Puppet Shark. I'd have to re-edit the video. He's not a sound wave. Okay. That's more work to do. We got that. Another time. Okay. And let's see. Okay, we got the graphic. Let's go back to our 1,000-word documents. Got it. Okay. So now what do we need to talk about? Now we need to talk about a few things right here. So let's put some notes, because I'm not going to write it out. I want you to think about it. And let's go down here and say 1, mention values in the output. 2, compare and contrast the values. 3, that's when I lose the gold medal. I think that's about it. Oh, we should mention unusual features. Oh, wait. Yeah. Okay. So I think this is about the main stuff to mention right here. You really need to make sure in these write-ups that you're talking about it. I guess I should put use context. Some of these things I've done for so long that I just don't even think about it when I use context, because all data needs context. I don't just want to say like the max is 5, the min is 2.6. I want to say, looking at or comparing high school GPA to gender, we can see if we have a ton of outliers, what do we say? You could say there are a lot of outliers. For females, there's a lot of outliers in the data set, with the most extreme being a female who had a 2.6 GPA and for the minimum, and a female who had a 5.0 GPA for the maximum. The males also had outliers, but only on the low side, where the males had the most extreme minimum, had the most extreme outlier with a minimum of a 1.8 GPA. Is this making sense what I'm saying right here? I just compared and contrasted the outliers, and I also made sure to talk about what the values were for these outliers and mentioned the males don't have a high outlier. Yep. And so then we would say something about the medians. The median, which represents the 50th percentile of GPAs for males and females, is 3.8 and 3.9 respectively. Let me repeat that sentence. The median, which represents the 50th percentile of GPAs for males and females, is 3.8 and 3.9 respectively. Females had a slightly higher median GPA than males, with only a difference of 0.1. The IQR, which represents the middle 50% of GPAs, which is a measure of spread, was 0.3. If anyone's wondering how I'm getting 0.3. Or I should probably do the males first again because I said males first last time. Oh, good. It's an easy one. So that's 0.5. And that's 0.3. 0.5, 0.3. So the IQR, which represents the spread of the middle 50%, it's probably an easier way to say it than saying the IQR, which represents the spread of the middle 50% of GPAs, context, was 0.5 for males and 0.3 for females. The female distribution has a smaller IQR by about 60%. I don't know if I'd say it that way. I'd maybe say or I could say the female's IQR is noticeably smaller than the male's IQR with a difference of 0.2. So I'm numerically finding the differences. Would our median be talking about the 50th percentile for the credit hours? I believe so, yep. The 50th percentile for credit hours for blank group and blank group. Yep. Great job, Madison. So, and everyone's doing an excellent job. Hopefully it's making sense how to like compare and contrast these and all that good stuff. More questions. All we're doing is we're just giving context to data. We're just like explaining what's going on. Awesome. That's what I like to see. I like to see that this makes perfect sense. And thank you so much, because I know people come back and like watch these office hours. Like some office hours videos get like 200-300 views. And I mean, we're just going over data. How many people got watching right now? How many people? 10 people. I'll take that. We're in double digits. 10 people. I like it. And when the projects get closer and the test gets closer, woo, then we get up to like 30, 40, 50. We've had 100 people. One of my favorite things. You're welcome, Karina. I'll do this again, probably. Sometimes I'm spontaneous. One of my favorite streams we ever did. So now I miss the holidays. It was right before the Stats 2-1 final. And I just logged on and I did something and I labeled it "'Twas the night before Stat 201." And I just went the night before the final. And I didn't label this video. Sometimes the semester goes on a while and I get a little burnt out. I think we all do. But I logged on and we had like 200-300 people watching. It was the night before the exam. So I went through and did a bunch of questions right here and talked about type 1, type 2 error. So we're talking about type 1, type 2 error right there. Here we're talking about look. So if you look at this right here, with this table, this is a what variable. What types of variables are these right here? So we want to investigate if Reddit really loves cookout. We sample 200 random students, random. So we've got categorical data, and we've got a contingency table. So with what you're learning right now, that should help you out for later in the semester. It's meant to like build the knowledge. We don't put like questions from the early part of the class on the final, but you're meant to like crab rave. Heck yeah, crab rave. I gotta remember I got that button. When we talk about more random later, I use the random crab rave a lot. I guess it's an effect, but it's on the main panel. But yeah, keep coming to office hours, keep asking questions. I try to do as many things as we can, and then I try to label the videos. And this semester I've been really good about, like, not that I got bad last semester, but it's just one of those things like you have to remember, oh yeah, here crab rave again. I can only play it for like 3 seconds because Monster Cat hit one of our videos with like a DMCA, not like a DMC takedown, but they put ads on our video. I've got my loads. I can mute my. What questions are there? What questions are there? I made like a mac and cheese dish. Yeah. If you have questions, let me know. Whatever questions you have. It's like silence. Let's see here. We were doing coding. If you have questions, be like, Brian, wait, can you walk through the write-up on visualization 4? Yeah. Visualization 4 is pivot, right? Let's go over. I think we have a pivot chart on here somewhere, right? Where is pivot chart? Where is pivot chart? Pivot. We did a pivot chart. We should have one. Or we could just go back over here. And here it is right here. That one's not my favorite. This one's really easy. I thought we took a screenshot of another one. That's that one. Oh, I keep thinking I see something. Give me 2 seconds. That one's not as fun. Maybe we will have to use that one. Oh, there we go. Here we go. Here we go. Awesome. Yep. So this one's a little bit more fun. We made this one. So this is, I'll label this part of the video the write-up for visualization 4. It's visualization 4, right? It's pivot, right? And then 5 is regression, 6 is decision trees. We got this. I need to mention the videos. I need to look at those titles this weekend and make sure everything's proper. Okay. So when you look at this right here, make sure, one, that your name is here. Don't put, it's not prepared for Brian Stevens, it's prepared by. So make sure your name is the name, like your name needs to be the name. So we need to mention things like, well, one, like always be citing numbers, always be giving context. So like give context. So give the context, always be citing the numbers. And so like, what is a strong sentence here? I'm going to eat a little bit of my food. Wait, I want you to say one sentence. So I'm going to just be right back in 10 seconds. Where's Brian? Ah! I know. I'll zoom. Took a quick lunch break. Our chapter 2 says I haven't completed it, but I just submitted it. Sometimes Canvas takes a moment. If you want me to check, Jordan, I can look. I'm back. I need a sentence. I need help. I don't know how to interpret this. I'm stuck. I don't know what this data means. It's got a lot of context on it. On the first part of visualization 3, should we just talk about the percentiles? Yeah, pretty much, kind of, sort of. Make sure to we're gonna have to, like, let's see here. We talked about that earlier, right here. So check out, especially, we can go back to that if you want, but check out the start of the video, and this is my the first 10-15 minutes of the video. Were you here for that, Madison? I'm trying to remember. Yeah, I think it was you, Madison. Pretty much, sort of, kind of like that. I think it was, right? Yeah. It was. Sorry, like, I'm trying to remember. I'm like, because I called you Maddie. Anyways, she was like, "Okay, this is my nickname." And don't eat too quickly, everyone. Oh no, worries. On the first part of visualization 3, should we just talk about the percentages of liberals versus conservatives? Yeah, that's pretty much it. And you want to compare and contrast them, because you want to make it clear, like, if one group is more likely to be this or one group's more likely to be this. Does that make sense, Maddie? You want to compare and contrast, where you can say, like, it's noticeable that more males, like percent, and make sure to mark the percent, like blank percent of males reported being this versus blank percent of females reported being this. Does that make sense, Maddie? And then, like, maybe subtract the difference, be like, this is a difference of blank between the two groups. So mentioning the numbers is key. Sure, which one, Ansley? Feel free to put it in here. Hopefully this makes sense for the write for visualization 4. You're welcome, Mary Beth. A survey of 12 gas stations produced the following prices for a gas station, regular gasoline. That's the stem and leaf one, right? And so here's my tips for the visualization 4 write-up. So mention the trends. I'm going to mention a few sentences here on this. Meeting later on. So what I would be writing, here's like one sentence I would write. In comparing somebody's born in Tennessee versus their family order, what we would notice right here, and you are making 2 of them. The first one has instructions, and the second one is like the freebie. So this would be like the freebie one. Does that make sense, Maddie? This is like the second one, and it's the freebie one, which you need 2 categorical variables, and then you need 1 quantitative y being displayed. So this could be your freebie one. So you technically, you don't copy paste mine, but you can technically make your own and do the same steps I did for any of the freebie ones. So when I'd write this up, I would say something like, there is comparing somebody's high school GPA by whether they're born in Tennessee and family order provides some interesting insights. We first noticed that the people with the highest high school GPAs are generally the oldest person in the family. But with a 3.83 for people born in outside of Tennessee, 3.83 for people born outside of Tennessee, and a 3.86 for people born inside of Tennessee or born in Tennessee. The lowest group of GPAs are people who are only childs, where the people not born in Tennessee had a 3.6 on average, and the people born in Tennessee had a 3.74 on average. Another thing I noticed is that people who are born in Tennessee consistently had higher GPAs than their not born in Tennessee counterparts, ranging from a difference of 0.03 for the oldest children to a difference of 0.14 for the only childs. Does everyone see how I constantly kind of mention these numbers and I'm giving context to what I see? So I'm mentioning the trends, I'm mentioning the highest and the lowest groups, and I'm making sure like I say what these groups are, as though you wouldn't even need to see the graphic to know what I'm talking about. So, and we'll do Ansley's question here next. But is this making sense? What you would like the sentences you'd be writing for the pivot chart? It's like be citing your numbers, be mentioning the trends, and kind of walk someone through as though they can't, like pretend someone can't see the graphic, and you need to explain to them everything on the graphic as though like they can't see it. So I think I think we're good on that. We're gonna do Ansley's question right here about the gas stations, the stem and leaf. I'm pretty sure. I think. Watch this. It's gonna be scary. 17. Oh, it's back here somewhere. I know it is. I saw it. That's not it. So yeah, it was. Yeah, and you could say if there's no real significant trends, there it was right there. Mine looks to have some sort of slight relationship right here. I would say there seems to be a slight relationship between people born in Tennessee have slightly higher GPAs. Also, it seems there's a slight relationship that younger children have slightly lower GPAs and only childs have slightly lower GPAs. The differences are small, but are a few tenths of a points between the groups. You know, with the biggest difference being between the oldest children born in Tennessee having a 3.86 and the only child's not born in Tennessee having a 3.60. The more you can mention the numbers, the better you'll do. Like the more you can kind of like be like, the biggest difference I see is between this group and this group. The trend I see is that oldest children generally have higher GPAs, 3.86 and 3.83, versus the youngest children have generally lower GPAs, 3.79, 3.76. But there is a bigger gap between the only children, which is not really a sequential thing. If you think like oldest, middle, youngest, that's more ordinal, but only child is not an ordinal categorical variable. It breaks the trend. So the more you can mention the numbers, the better. The better. Mention all numbers. Or not all. You don't have to mention all, but mention as many as you can. This one right here, this is a stem and leaf. So we're on Ansley's question right here. With this stem and leaf, what this represents right here, 2.2 and then the 5, means that you're going to see 2.25 up here somewhere, or you should. Do we see it? 1, 2, 3, 4, 5, 6. There's 12 numbers on the screen. What number would this be right here? This number right here is where? What number if you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12? What number is this for a gas price? Which gas price number is this one right here? It's in all the stem and leaves, so it should definitely be up here somewhere. Is it the first number? Yep, exactly. Yep. Nice job right there, Jordan. Excellent work, Jordan. It is this number right here. That is this right here. So it's a price between that. Like the 2.25 means it could have been 2.52. Don't worry about it. Just pretend these last numbers don't even exist. That's the best way to view this problem, is to be like, that last number doesn't even exist. But now let's look at this 7. Does this 7 exist up here? What should you see? Like, what 3 numbers should you see if something 2.27 exists? Everything ends in a 9, so you can guess the last number. What should you see up top if this number exists up here somewhere? What should you see up top if this number right here? Exactly, Ansley. Great job. And we do see it. That means which of these answers is wrong right now? Which of these answers is wrong? Because we do see this number up here. Which of these stem and leaves? I forgot the name of them for a second. Which of these stem and leaves? I was going to say box plots. We were just doing box plots. Which of these stem and leaves is wrong because we see it? B is wrong. So we've eliminated B. Probably, do you see how this is 2.0 and then it should be 2.05, 2.07, 2.08? There should be 3 observations. 2.0, and you know what? I don't see it. I don't see 2.05. I don't see 2.07. I don't see 2.08. I do see 2.01, which is in both of these. But let's go to something this one has. You see these 3s right here? 2.23, 2.23. So do we see that? I see it right here, and we should see a second one, and we see the second one right here. Is this making sense? Well, Julia, we'll do that next. Nice job right there. Oh yeah. We'll do that one next. That one's a good one to like understand the trick to it. So this right here, does that make sense, Ansley, how I eliminated this down and was like, that's the one it is. Like process of elimination, identifying which numbers are which ones, and then we have it identified. So hopefully that makes sense. And before I go to the next questions, I'm going to look at this distribution. And is it left skewed or right skewed? So which way? And I wish we were doing this one because that one's super skewed. That one is super skewed in one direction. So this one right here, it's skewed to the left. You're correct because it's skewed to the low side. This has a tail going to the low side. This one is pulled to the high side. Watch out. If you flip it down, the number line will be reversed. So this is left skew because it's pulled to the low side. So we're going to say it's skewed to the left. The prices seem to be centered around where? 2-1 something. I think that. No. Let me look again. Where's 220? Yeah, 220 is right. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's literally the median. Great job, Jordan. Yep, that's the median. I thought something was wrong about that. So if you go in 6 numbers, 1, 2, 3, 4, 5, 6, that's the 6th number. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. That's the 6th number. So it meets in the middle. That is the median right there because we're saying it's skewed. The prices range from, I got this one wrong yesterday, 2.019. I got this one wrong. Not today, my Pearson. Not today. To 2.279. It's so easy to make mistakes. What's an unusual feature? There's a gap. So want that one? No gas stations charged between this and this. That's a gap in the data. You notice right here, outliers and gaps are unusual features. And I think we have done it. Not today, my Pearson. For these, let me see. How well do I know this? Is it question number 7? What should be 8? I was going to choose 8. I did it. I got it. Okay. So chapter 5 is next week. And chapter 5 is a chapter that destroys everyone. But this will give you a head start. You're like, what? We were having fun, nice office hours, Brian, until you just, we need some, let's put on some music. Chapter 5 is scary. But don't worry. This is the start of understanding chapter 5. This is the mean of the distribution. The mean is the center. It's the average of the distribution. How many standard deviations do we generally go up and down on the normal curve? So who knows who's been here practicing? How many standard deviations do you go up and down from the mean? When you draw out the normal curve, how many standard deviations do you go up and down? So how many standard deviations do you go up and down? 3. 3 standard deviations. So with 3 standard deviations, let's go right here. And this is why I definitely make help videos for these ones, because sometimes one of the questions is a little bit tricky, and I do consider this one like, they don't even mention in their book really well. So very sorry. Someone's like, how's I supposed to know this? Oh no, I'm sorry. That's why we'll just say the answer. If you were to go right here at 2.2, which is the center, and we're going to choose 2.2 because it's the balancing point, not because it splits it into 2 equal parts. Wow, it's like, really? They didn't even give the wrong answer. Oh, wait. Oh. Wow. If it splits it into 2 equal parts, that's the median. But we're going to say it's the balancing point, which is like, it balances on that. So now, when we look at the standard deviation, and this is like, when we try to understand the standard deviation, it's a typical distance things are away. And if you understand it by definition, which we do give the definition, would you say most things from the median, and like a typical thing, is usually about $1 away, which would be all the way down here. Is a typical thing about $1 away? Does that even make sense if we say, like, if we use the definition of a standard deviation, which is the typical distance something is away from the mean? Are most things about $1 away? That's where, like, like a usual thing is about $1 away. Like, I'd expect something about $1 away. Does that make sense? Like, that doesn't make sense. Because, like, what the heck? Something's $1 away. That's really far for this distribution. How about 50 cents? 50 cents would be down here. Is this how far things are usually away from the mean? And I'm not saying, like, that covers everything. But if I were to say, imagine this. I think the way to make it make sense is if we draw something out here and we say your friend shows up at 5. Your friend's going to show up at 5 p.m. and they're usually about 5 minutes earlier or late. So 5 p.m., and they're usually about 5 minutes earlier or late. So if they're usually about 5 minutes earlier or late, then here's 5:05, 5:10, 5:15. So most of the time, here's 4:55, here's 4:50, and here's 4:45. If they're usually about 5 minutes earlier or late, then that's the typical thing you would expect, but there's more variation. So the standard deviation for this distribution would be 5 minutes. Your friend usually shows up at 5 to your house, and they're usually about 5 minutes like around that time. They could show up at 5:10, they could show up at 4:50, but this is the variation around it. So when you look at this distribution here, what is the typical distance things are away? You could kind of estimate it by just looking at the axis right here. I wouldn't, you want to go 3 down, but this is 2, so it's a little bit less than 20. But does that make sense how I was able to figure out like a typical distance things are away? Like this looks to be about how far typically things are away, like somewhere in here, about 15 cents. You could also divide the whole number line by 6. It does depend on the graph. Yep. And we'll use the standard deviation for normally distributed data, Julia. Great answer right there. So we do say in class, which should be a good way to figure this out. You're welcome, Julia. Glad this helps a lot. You should think of the standard deviation as a typical distance things are away from the mean. And, a standard deviation visually, which I think we show this too in class, but I do understand. Don't worry. This is like one of the questions where a lot of people are like, how the heck am I supposed to get this question? The standard deviation visually is going to be this distance right here. It's that distance right there, and that is 1 standard deviation. The notation for standard deviation is this. That's plus or minus 1 standard deviation from the mean. So there's the mean, and there's plus or minus 1 standard deviation, and we usually go out 3 standard deviations. We go 1, 2, and I drew it horribly today. Draw better standard deviation curve. Normal curve. Oh my gosh. I spent my whole life drawing these. I should be able to draw better ones. Go up 1, 2, 3. Down 1, 2, 3. And it's usually, I did pretty good that time. It's where the derivative changes. And sure, center's off. Not perfectly symmetric, but have a question about visualization 3 is distribution gender and political views moderate. Also, what does practical difference mean? So make sure to mention the difference between those. Let's pull up the thing we have for that. So the stronger an association is, should be graphic 36. So the stronger an association is, and I have a different graphic up here right now, but the bigger the gap right here, that's not easy to see. The bigger, we're going gold pen today. Now rainbow pen back. The bigger the gap, there we go, that works. Does this make sense what this gap is right here? As I just fight the computer. The spread is the min to the max, that's the range. Range is one measure of spread, but I don't know if it wants IQR range spread. There's 3 measures of spread: range, IQR, and standard deviation. So when we talk about like, what is this difference right here? We need to compare the what distributions. These are keywords we should know. What distribution is this? And this is another one of those. So if we want to say if there's a practical difference right here between this, like if we analyze this graphic. So conditional, nice job, Mary Beth. Excellent. Let's throw some 10 points. Amazing questions today. Thank you, Mary Beth. Those are conditional distributions because given somebody is male and given somebody is female, here's the probabilities. And so when I compare these, I'm going to say things like, given someone is female, the probability they've broken a bone is 40.3%. There's the group up here. Given someone is male, the probability they've broken a bone is 54.65. So I'm going to probably subtract these differences and say, this difference between males and females for breaking a bone is 14.52. This seems to be a somewhat moderate association where males are more likely to break bones than females. Does that make sense right there? So the practical difference is this number right here. That's like, I'm not just saying there's more. I'm saying like, here's the actual amount. And then I'm kind of saying it's moderate. And the bigger the gap, the stronger it is. I think I have I don't know if I saw that graphic up. Let me think. I think this might help to see it. I think we still have it up from way earlier this week. Here we go. This is where you'd go from weak to strong. So the bigger, this is a more practical significant versus this one versus this one. Exactly, the larger the gap. And the gap is the difference between the conditional distributions. So given someone was in this group versus this group, there's a much bigger difference between the probability of Y. So the more practically significant it is, the bigger, like, you would say like, oh, this one has a very low probability versus this one has a very high probability. But over here, there is no, like, this is not associated. It's beyond weak. It's no association because both groups, like in this example below, have the same probability. Yep. And yeah, and so sometimes you might have, which is really good question right there, because yours looks different. Yours is going to look more like, tell me if yours looks something more like this. I've seen what yours looks like, the graphic. And I need like a whole bunch of colors now. I need one more color. This should look something like this. Does your, yep, and I think you're saying yes, that's, your graphic looks a lot bit more like this right here. And if we were to analyze this and we had here, like, we'll just put some numbers on these for the moment. Let's just call it like group A and group B. No, come on. I just wanted to erase that. Group A, sure. Group A, Group B, and we'll call this level 1, level 2, level 3. Where looks to be the most practical difference right here? I'd say there's two areas of practical difference, which I would probably be writing about the most. Where does there's one, like, if you were to say, like, people A have this amount for this, and you could look at the conditional distributions, which are the row percentages. But when you compare A and B on what group, like, there's two of them. So 2, like, if you compare, so you're really close. I wouldn't use 2 and 3. Yeah. Because if you compare, like, the amount of A's who fall into 2 versus the amount of B's who fall into 2, that's a pretty big difference. And then there's one other one I would definitely mention in my write-up. Damn you. There's one other one I would also mention. And then I might mention that A and B are similar on 1 and 2, and I might mention those percentages. So 2 looks to have a pretty, which I can't remember the answer. So I'd say, like, 33% of people in A reported group 3, or like reported level 3. Yeah, 4. This looks to be maybe 10%, and this is like 20%. So people who are A reported 10% of the time level 4. People who are B reported 20% of the time level 4. This is a difference of 10%. People who are group B are more likely to identify with level 4. Does that make sense right there, as I like give some fake percentages that I'm making up? And yeah. You're welcome. No, excellent work. This is, if you understand how to understand this graphic and you understand the conditional displays, the marginal displays, all that good stuff, you're good to go. It's just practice. And I try to, do examples that, one, kind of show the concepts of it, like what's going on when we go from weak to strong relationships. And so this is just kind of the basics of it. And then hopefully I can show like your example. Like, that's how to tell if something is practically significant. Can you only take the quiz once? So you get 5 attempts at the quiz, and to get attempts 2 through 5, what do you have to do? The first attempt's free. To get attempts 2 through 5, you have to get at least an 80 on the homework. And so I might send reminders tonight to people. But so the quiz is due tonight. I'll probably be sending out reminders like, please do the quiz. Please try to get 100. Try to be part of the 100 group. Man, last year at this time, I always have a goal. See, it's not fair if I tell people have things in life that maybe, like if you are sick, I got a 97, but I don't know if I should, give it another shot. Give it another shot. If you want, you get extra attempts as long as you have an 80 on the homework. Give it another shot. It doesn't help it doesn't hurt to review it. You can probably complete it in about 5 to 10 minutes. If a question counts you wrong unfairly, just tell me. And you can't lower your grade by taking it again. And the more 100 you get, it's like, boom, another 100 in the grade book. So, and if you want, like, let's say you have to go to work in 10 minutes, don't take the quiz again. Let's say you have stuff due for other classes and you're falling behind in something, don't take the quiz again. But if you're like, I'm not doing much right now, I got 97, maybe I'll try to get 100. Yeah, nothing wrong with that. You'll be reviewing and you can only increase your grade. Does that make sense, Ansley? I was just thinking through like out loud that it wouldn't be fair to put on my students like, this is the semester where everyone makes an A. There's circumstances that some students, like I talk about a student who's happy to make a B. You're welcome, Ansley. Great work. Yeah. I want everyone to make A's, but I understand when circumstances don't allow for that. You know what we might do? While there's questions, I'm going to try to fix something. If you have questions, let me know. You're going to see behind the scenes right now. This should be camera green screen. It's cutting off less of the chair. If you look back in the video, the chair was a little bit getting green screen. So you can see a little sparkle on the green screen on it. So much work with the green screen. Got to get it perfect. Got to have it. And my hair is doing less of a. It's like if you. Green screen's doing right. We'll put on some music here. I think we're near the end of office hours. We'll see what questions people have. Points. Check out your points. Let's see right here. So this is nice and relaxing. I don't want to hype people up at the end of office hours. We'll hop over here to the main screen. Put some 80s in the background. Puppet Shark. Did you have a good day, Puppet Shark? Yeah. Thank you, Puppet Shark. Oh, no, HG, do you have a question? HGT? Do you have a question? If you have a question, let me know. I was fixing camera. Talking to Puppet Shark. Yeah. Just waiting for that creator to find out I use their thing. And to be like, thank you. You're only bringing good attention to what we do. Last two DataCamp questions. Did you send them to me in Discord? Let me see. The last two on DataCamp. Let me see here. Go get those last two. No, I just got out. No, no worries, no worries, no worries. Go to DataCamp. DataCamp. What are the last two questions on intermediate R? And great job working ahead. This is not the easiest of assignments. I'm really proud. Like, so many people have completed this assignment or started it. Go to the main screen. So utilities. The thing is, I've completed all these, so if you do this, you see the answers. Let's look at the last two are. Is this what you're in? Is you're in the utilities section? Got it. Course outline. Yeah. Send me your write-up, Marybeth. Excellent work, Marybeth. So, DataCamp, thank you very much, DataCamp. I don't think they seem really nice. Basically showing one of the answers right here. Log in and out are already defined in the workspace. Calculate the difference between login and log out time online. So time online, there we go. It's just a difference right here between the two vectors. So these are already, yes, I can do that. Did I submit the answer? No, I ran the code. I'm so glad that works now. They've got night mode on. But login is a vector and log out is a vector. And these are time vectors. You can see the UTC on them. And then we're going to calculate the difference. Inspect the variable time online. Just look at it. Calculate the sum of how long people were online and calculate the average time. Is this the one you were talking about? HGT, is this the one you're talking about? They're talking about how to use, this is if you know the as family of functions, as will store something as something. Let's put on a little music right now. Music. Which one's yours? Which questions are yours that they say? You might be in a different group of questions. Maybe they changed it since I took it. Brian, can I email you after write-ups to make sure? Yeah. I'll double check. Write your own function 3 for the first one. You might see, let me see here. Let me restore the screen. There's some Mosaic plots as we listen to nice piano music. So you're in the function section, it sounds like. Functions. Okay. This is a different way to load packages. First part of the question. Write your own function 3 for the first one. Write your own function 3. Here it is. Okay. Finish the pow2 function. Okay, do you remember the difference between an argument with and without defaults? Okay, cool. So we're doing defaults. And I'm going to bring this over to here. Bring it into R. Nice piano music as we finish with some DataCamp. So, finish the pow2 function. That's like a how-to function. Well, that's the answer. Don't look at the answer. Because I already worked it. Do you remember the difference between an argument with and without defaults? So, what is going on here? So, HGT, do you see... Bring it up to chat. Do you see this right here? This is an argument, and does this have a default right here? Does this have a default or not have a default? Does this currently have a default right here for X or not have a default for X? Does X have a default? We did visualization 3 a lot today, JG. Great question. And this does not have a default. If you can't find the video, let me know. We went over the how to do the write-up for all of visualization 3 today. So check it out. And if you can't find the videos, let me know, and I will point you in the right direction. Put on doubt. So this does not have a default. How do things look when they have a default? When you're building a function, how do things look when they have a default? How do things look when they have a default? Hint, look over to the other argument. So X has no default value. How do things look when they have a default when you're defining the function? So in the defining the function part, the arguments for the function, when something has a default, you'll have the variable name. So there's a variable name when you're defining the function, and then it'll have a what? What will it have when it has a default? What will a function that has defaults for arguments have? So if this has a default right here. When arguments have defaults, they have what? Does anyone know? You're kind of on the right track. So let me show you. This function has no default now. Just like this function, where I go to, I'm just gonna do a print, and let's go word equals Brian. And if I go print word, and I say print word, so this function has a default for print word. And if I go to print word, it'll now print Brian. But now this function does not have a default, and it says there's no default. So when do functions have defaults? So with the examples right here, when do functions have defaults? Like now this function does not have a default, and now it does. So no default, default, no default, default. And if it has a default, it will print. And so it doesn't have to be equals, good job right there, you're on the right track. It doesn't always have to be equals true. It just has to have an assigned value to it. Does that make sense, HGT? It just has to have an assigned value. So it has a value right there. Like this function has a default for word, and that default is Brian. This function has a default for print info, and that default is true. So if someone does not enter anything for word, it'll put in Brian right here. You can change this to be Darren, and now the function will print Darren because it's not going to use the default. So if you don't have a default, you need to put in that word, because now without a word there, it'll say it can't run the function because there's no default. Word is missing with no default. Is this making sense what defaults are in functions? Like the main thing, you're welcome, JG. Does this make sense what a default is in a function? A default is a value that is used for a variable where if someone does not input a value, it'll be used by default. That is what a default is in a function. Like use this by default. And I've been getting this feedback. Did you correctly define the function powtow running powtow false generate an argument? You might not have a. Let me send me your code. Are you on Discord? Are you on Discord right now? If you can send me your code on Discord. If you're on Discord and you can just copy paste the code you have in. Not on your PC. You might just send me your code later. Because I have to see it. Let me read the error again. Did you correctly define? Okay, so it's actually giving you an error on this. It's saying you didn't define it. It looks to be the errors there. And no worries, no worries. It's just, it's hard to know because if we run my function right here, let's run the function. I haven't done this one in so long. I'm like, what does it even do? So you print 5. So it says 5 to the power of 25 is this. So this is if we put print. So we could put false right here and we won't get the print. And so this just prints out the statement right here. So it's just going to store into it. This is like power 2. Yeah. So it's power 2. That's, yeah, it's not pow 2. But it's the raising something to the power of 2. And then it also prints out the statement if you want it to print. So let's just run through what this does. A user inputs the value X, and then the print info is an argument on whether or not it'll print this right here. We're using the print paste format just because paste allows us to put in additional arguments. So you want it to just print it to the screen. This works perfectly fine. If I was doing this, I'd probably use cat. Just personal preference right here. Either's fine. Don't use cat for yours. I just like cat because it puts it to the screen like that, and then we have that problem. See, okay, I'm not going to change it too much. I'm just writing it the way I would write it. I would use multiple cat pastes. So if somebody puts print info true, it will then print to the screen blank to the power of 2 equals this. And it's going to take your X value, whatever you input as your X, and also take the Y that's solved of raising that to the 2nd power. And then it also returns Y right here. Now, a big thing I want to mention is what will this do? Will this return blank to the power, or 5 to the power of 2 is 25, and then return 25, or this will this just return 25? So HTT, will this just return 25, or will it return 2 things where it says blank 5 to the power of 2 is 25, 25? What will this return? So I did not specify print info. I did not specify what print info is. So what will this return then? Will it be 2 things or 1 thing? This is the big thing about defaults. It'll actually return both, because without, so don't worry. Without print info true, what will it assume for print info true without me specifying anything right here? Without me putting print info equals true, what will it assume by default? What will it assume by default for print info? Can you go over this question in the stem and leaf display? Yeah, let's do it next year. 51 regions and the millions of people. Yeah. I'll do the one next year after this. You got it, Ansley. So, yep, exactly. And so that will, there it is. It's because I changed this. Yeah, it's printing out both. Why is it not 2 lines? So it does print out both right there. It's going to drive me nuts if it's not 2 lines. There we go. Is that making sense, HDT? So I don't have to specify the second argument, but I can specify the second argument like that. So when you specify the second argument, you can control what it prints out, but also it's going to have a default value and it will print it by default. Now, but check this out. You ready? Will this print out? What will this print out? 25, or will it 2 things or 1 thing? Will this print out 2 things or 1 thing now? I changed what the default is. So will this print 2 things or 1 thing now? So look at the default. And so print info is by default false. So I changed what the default for print info is. So now what will this do? 2 things or 1 thing? Bingo, you're getting it. Nice job, HTT. Let's throw another 10 points to the chat. Is it making a little more sense how to use like defaults and stuff? It just takes and assigns the value of that to the argument, whatever, or the argument. That's correct. Awesome. Great job. Let's look at this this stem and leaf plot. I think that's question 18. No. Here we go. Okay. This one's not that bad. It's not as fun, though. Let's put on a little more music. Sad chill? This is like vaporware. So I keep saying. Okay. I got to go out of the way of the question. What measures of center and spread are appropriate? So, it was Ansley. No problem, HGT. Good having you here. Thank you for swinging by. So, Ansley, they also different in the video. Maybe I just watched the wrong video. Check out the very start of this. Check out the very start of this video, and I do different things. I don't do the exact one that you do, JG, a lot of times. I try not to do the very graphic you'll be doing to analyze the same thing. So I try to like help you understand how to analyze the graphic, and then you analyze yours. So I rarely, if ever, do the exact ones that are done for your assignment. So that way you interpret your own graphic. Yeah. Just don't be confused by that. Don't be like, I should do the one Brian does. Do whatever the instructions say for the assignment. What way is this skewed? Is it skewed to the high side or the low side? What way does the tail go on this? You're welcome, JG. Great questions. Is this skewed to the right side or the low side, Ansley? Or anyone's free to answer. Right to the high, left to the low. What way does that tail go? Right to the high, left to the low. What way does the tail go? Nice job, Ansley. Goes to the right side because it's pulled to the high side. So that's right to the high. Watch out. If you drop it, the number line's reversed. So because it's skewed, what would be the proper measure of center and spread? So because it's skewed, what's going to be the proper measure of center and spread? So we were saying this is definitely skewed. So what's going to be the proper measure of center and spread? We always pair together the mean and standard deviation and the median and IQR. Those are the only two answers. Great job, Ansley. You're 100% right. Because of the skew, it's median and IQR. If it was normally distributed, like a previous graphic we saw, it'd be mean and standard deviation. But because of the skew, median and IQR, which are robust to skew, means they're not impacted by it. Without doing any calculations, which will be larger, the mean or the median? And so what follows the skew? What follows the skew? Think about these three numbers. 1, 10, a billion. 10 is the median. 110, a million. 10 would not move. But when you have skewed data, the mean is going to follow the skew. So the mean will be larger than the median because the data are skewed. I think that's right? The mean will be larger than the median. There we go, got it. Now, these are the not fun parts. The median, with 51 countries, we need to do a little calculation right here. Here's our right skew distribution. With 51 countries, we take 51 and we add to it 1 and we divide by 2. The 26th number would be the median. And with 26, so the 26 numbers, and then there'd be 25 numbers down here and 25 numbers up here, because there's one number in the middle. So it's the 26 number is the median. You could bring this into jump probably. So the 12.5th this way and the 12.5th this way is going to be those divided in two data sets. So let's find that median. Let's listen to some more music right here. Let's go back to music. We need one more song at least. Let's go to, I like this one, just chill. Let's go back to the data. The 26th number. 1, 2, 3. It's hard for me to count and like look. Okay, I'm gonna make a mistake. Let's do this. 1, 2, 3, 4. You're gonna hear me far away from the mic. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 23, 24, 25, 26. We landed right in the middle right there. That is 5. So the median's 5. The IQR is going to be the 12.5th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So luckily we landed right in the middle of the 2s. That makes this number right here the 25th percentile. Let's go back in from this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.5. So it's 2 to 9, 7. So luckily we land in the middle of a whole bunch of numbers. We don't have to average things together. So once again, the number for the Q1 was right here, and the number for the Q3 is over here. The distance between 2 to 9 is 7. The distribution of ages is unimodal. There's the mode, and there are outliers. There's one. It's right there, and that is another 100. I was like, please be 100. Does that make sense, Ansley? Do you see how we were able to find like Q1, Q3, all this good stuff? Mubot, office hours are almost over. We know how to tag me with the thing right there, Mubot. Let's go say hey to Mubot. We haven't said hey to Mubot in a while. Where's Mubot at? You're confused about the IQR? Let me go back. Mubot. Not today, Mubot. So the IQR, let me go back to that data sheet I was showing. Since there are, it's gonna be all the way down here, around 42 data sheets. So since there are 26 numbers, or excuse me, 51 numbers, here's how we found the IQR with Christmas mode right here. Since there are 51 numbers, the 26th number is the median. And then I took and divided both those data sets into their own kind of 50-50s. Does that make sense, Ansley? Like, to find the Q1 and Q3, I just divided those numbers together. Like, I took this and treated it like it's its own data set, and took this and treated it as like it's its own data set. You could enter this all into Jump. That would work too, but that's way longer, like to type it all in, and then you could make an error. But you have to find the 12.5th number going inward and the 12.5th number going out backwards. Does that make sense, what I'm doing right here? If you want to see me count it again, I can go back over to here, and you count in, you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.5, and luckily you would be averaging 2 and 2, so that's 2. Then you go back this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.5 right there. Does that make sense? How I'm they're ordered right now, so I'm going like from the highest number back in 12.5 numbers. Nice job, Ansley. Nice job. That one's, some of these are less fun than others. Like if you can't enter it into Jump, it's not as fun. We don't like data sets that are not fun. Mubot, how are you doing? Mubot, don't ever be evil again. Mubot, no Mubot. Mubot. We'll find more about Mubot later. But for now, I'll be back. Talk to everyone later. Bye for now. Bye.